Hi there everyone, welcome back to Cody's Lab. So I found this supposed rough diamond on eBay. It was $120, which was a pretty good deal for a diamond that size, and I don't really care what it looks like. I just wanted a large stone to play with, and so I went ahead and purchased it. It's not really something I could, cut into a piece of jewelry or anything, but it should have all the characteristics that you would expect a diamond to have, such as the incredible hardness. So that's the first test we'll do, is to see if it is as hard as diamond. So to test the hardness of this stone, I'm going to do a scratch test. Now I'm going to need something very hard to compare it to. Diamond is a 10, and so I want to see if I can scratch something that's a 9. This here is a piece of synthetic ruby, which is corundum, which should be a 9 on the hardness scale. So let's see if the diamond can scratch it. Alright, so far it looks so good. Just wipe that, make sure it's not dust. Yeah, that's a scratch. Looks like it was able to scratch the corundum, so that's 1 point towards it being a diamond. The next test I'm going to do is measure its density and see if that corresponds to what I would expect for diamond. So to do that, I first need to get its mass. It's pretty easy, just set it on a scale. So in order to measure the volume of this stone, I'm going to use a little trick that I've used in another video, which I suspend it in some water and measure the weight of the water that is displaced. So you see the wire was displacing a little bit of water there. You can actually see what the volume of the wire is. But the wire should cancel out because I've tared it. And now we just put the diamond in and we can measure the volume of the diamond. For smaller stones you might have to use a denser liquid such as mercury. I suppose I could also use a clear sea solution in order to measure the density of the stone. Unfortunately, I still haven't evaporated it down. So it looks like we've got about 1.030 grams. That corresponds to about 1 milliliter of volume. Awesome. So to find the density, I take the weight in grams and the volume in milliliters. It looks like that comes out to about 3.31 grams per milliliter. Now I believe the published value for diamond is 3.51-ish, so it's a little bit underdense. My guess is the cause of that might be some voids inside of the stone. Like it's not a solid crystal, like there's like some cracks and holes in here. Also, this value I'm sure is given a range of different densities that diamond can have. This right here is a little different, but it's not enough for me to say that this is not a diamond. It is enough for me to say that this is not, say, cubic zirconia or something, which would be much denser than diamond should be. So this is a checks off. So diamond is really conductive of heat, and so it will change temperature much more rapidly than, say, quartz. So I've got a piece of ice here. Let's stick it on at the same time and see if we got any kind of a difference. Okay. Oh yeah. I could definitely feel that the diamond changed temperature faster. Got a nice puddle of water going there. The heat does transfer very quickly. Diamond should be about as conductive of heat as copper is. Body temperature, put it on the ice with the diamond. Look at that, melted right through it. So now with the other gemstone here, just kind of, and see, I don't feel the heat at all here. Now that I've confirmed that this is a diamond, I am really curious, could you cut this using a water jet? So I've come to visit the water jet guys, and I'm going to challenge you to see if you can cut that with your water jet.
I don't think we can do it, but we'll see.
I think we can. So if you guys want to see their attempt, I'll link it down in the description and probably up here. So you head on over there and check them out. Okay, how's that?
Hey, ready? Yeah.